Hi everyone! We're going to go through calculating molarity of a solution. Now, calculating molarity is one of the most important concepts for doing lab work in AP Chemistry. So make sure that you can calculate molarity and you can use molarity for a variety of applications, very similar to what we're going to look at in a lot of these examples. So with this, it says 3.85 grams of NaCl is dissolved in enough water to make 81.0 milliliters of solution. Calculate the molarity, or the concentration. So if you remember, molarity, which is represented by a big M, equals moles of solute over liters of solution. Now it's important to recognize this terminology, solute and solution. So moles of solute is moles of what you're dissolving, liters of solution is your overall solution. Well, let's go through the problem and let's do some underlining and some circling. So we know that we have 3.85 grams of NaCl that's being dissolved. So what does that make the sodium chloride? Makes it the solute. So our NaCl is the solute, it's dissolved in enough water, water is the solvent, to make 81 milliliters of solution. So overall we have 81 milliliters of solution, and then calculate the molarity. So looking at this, moles of solute, okay, right now we have grams of solute, somehow we need to get from grams to moles, which hopefully you can do. And then we need liters of solution, right now we have milliliters, so we just have to make sure that we can get to liters. Now there are a couple different ways you can go about solving this problem, and I'm going to show you both ways. So let's calculate molarity. So just to remember, molarity formula is up here. The first way that you can solve this is by converting both of your givens to the unit that you need to plug into the molarity formula. So we start with grams of NaCl, and I go to moles. What is this conversion factor called? What is this? It's the molar mass. So I use the molar mass to go grams to moles, and I get my moles of NaCl. Notice I went out to 4 significant figures. You just want to make sure that you go out to more than what you need, just to make sure that you have that extra precision and accuracy as you work through your problem. Then we have milliliters. We go milliliters to liters, just divide it by 1,000, and we get liters of solution. So now I have moles of solute, I have liters of solution, and now I can plug it into my molarity formula. So molarity equals moles of NaCl over liters of solution. Again, notice that I'm using the moles to more significant figures. You can actually just leave it in your calculator and just divide by the volume, and that's going to also make your answer much more accurate because you have more significant figures. So from this formula we get 0.813 molar, big M. Okay, so the large M represents concentration, represents moles per liter. The way that you say it is molar. So 0.813 molar. Notice I have 3 significant figures because in the problem both of your given values had 3 significant figures. Now the second way that you can go about solving this is actually taking the information that you have and putting it together in a way that you could solve for molarity, and then you just take it out using dimensional analysis. So if we look at this, what I did is I took my solute, okay, I took grams of solute, and I put it over my volume of solution. Now notice right now we have grams over milliliters. We need to get to moles over liters. That's possible. We can cancel our units using dimensional analysis. So I actually started with my volume because volume is always just a little bit easier to convert. If you know, just by looking at this, that it's 0.081 liters, just put that on the bottom. But I started with milliliters, milliliters to liters. Okay, always use the 1,000. Now notice that because I want milliliters to cancel on the bottom, it has to be on the top. Okay, so my milliliters cancel, I have liters on the bottom. So my liters is good, right? Volume is good. Now I'm going to come back and I'm going to look at my mass. So right now I have grams of NaCl. I just used the molar mass, grams to moles, and my grams cancel, and now notice we have moles on top, liters on bottom, and that's what we want. Now if you multiply this out, you divide by what's on the bottom, you get 0.813 moles per liter, or 8.813 molar. Now notice, these are two completely different ways of solving the problem. You're still essentially doing the same thing, it's just set up differently. Whichever way you do it is fine, because notice, you get the same answer. So you're going to find as we work through problems that there are more than one way to solve a problem. And if you even found a different way than I did to solve it and you still got the same answer, use that way, that's fine. But notice there is more than one way to solve a problem.